Hey guys, welcome to Pre-Calc Lesson 12.3, Finding Limits Analytically. All right, so again, let's just review what is a limit. Remember, a limit is simply the y value of a function as x approaches a number. So anytime you're asked for a limit, it's simply the y value of the function as x approaches a number. So ways we can find a limit. All right, well, first of all, we can find a limit graphically. We did that in the last lesson. You'll be given the picture of the function, and you approach either from the left or the right, or you just find the limit, which means you're approaching from both directions. You can find a limit numerically. That's using the table that we did in the last lesson. So plugging it into y1 in your calculator, creating a table, and finding what the limit of the function is that way. And then what we're going to do today is we're going to learn how to find them analytically, which is basically using algebra. Next, we have techniques for finding limits analytically. The first method, direct substitution. Here we've got a function f of x equals x squared plus 3x minus 5, quadratic, parabola. I want to find the limit of that function as x approaches 2. Well, the first thing you would try to do always when finding limits is this direct substitution. So I'm going to take this function and plug in a 2. 2 squared plus 3 times 2 minus 5. All right, some quick arithmetic. 2 squared is 4, plus 6, 10, minus 5, that's 5. That is the limit. So I found the limit, but what does this mean? Well, remember, what I'm talking about here is a parabola. All right, and on that parabola somewhere I have a point that has an x-coordinate of 2. Now what we're doing when we're finding a limit, we're really not evaluating the function, but we're looking at what y value we're pointing to as we approach 2. So in this case, obviously that would be 5. So that point is 2, 5. Okay, well, what happens when direct substitution doesn't work? Well, then we're going to factor, simplify, and then try direct substitution. Okay, so in this example here, you can see I want to take the limit of this function x squared minus 25 over x plus 5. I want to take the limit as x approaches negative 5. Well, I think you can see if I put a negative 5 in here, all right, well, let's just do it. If I put a negative 5 in there, I'm going to get negative 5 squared minus 25 over negative 5 plus 5. That's going to give me 0 over 0. Obviously, that fraction is undefined, so I'd say the limit does not exist. However, the limit does exist. So what we're going to do here, factor, simplify, then direct substitute. Okay? So let me just get rid of this stuff here. And let's factor this. So that's going to be x plus 5 times x minus 5 over x plus 5. Now I can cancel these, so now I have this expression x minus 5. Now I don't want you to get confused here. That is not the same as the original function, but that's just an expression that I can use now to find the limit. So the limit of f of x as x approaches negative 5 is now the limit of x minus 5 as x approaches negative 5. So now if I plug negative 5 in, I get negative 5 minus 5. That's negative 10. That is the limit. Well, visually, what does this mean? What does this look like? So I don't even really need to know what this function looks like. I'm going to have some graph that looks like this. And what happens is, as you approach from the left and as you approach from the right, you're approaching the same value. So in this particular case, that point's going to be negative 5, negative 10. Now, if you notice it's an open circle, we call it a hole in the function because it doesn't exist. When I tried plugging in negative 5 into the original function, remember, it did not exist. But the limit exists because we're pointing to that same value. Let's try one more like this. All right, so in this particular function, I have x plus 4 over x squared plus 6x plus 8. And I want to find two limits here. I want to find one limit of the function as x approaches negative 4. I want to find another limit of the function as x approaches negative 2. Well, First, I would try and do direct substitution. But usually when we see a quadratic in an expression when dealing with limits, I'm going to want to factor that. So if you notice, this is going to factor to x plus 4 times x plus 2. So I'm going to be using that denominator. And I think it's pretty obvious to see if I plug in a negative 4, that denominator is going to be 0. So it would not exist. If I plug in a negative 2, that denominator is also going to be 0, does not exist. So what I'm going to do is I'm going to factor it, already did it, and I'm going to simplify. So x plus 4 cancel, and the expression I'm left with is 1 over x plus 2. Now again, that's not equivalent to the original expression, but I can use that now in my limits. So this limit here is going to be the limit of 1 over x plus 2 as x approaches negative 4. So what I'm going to do is direct substitution. 1 over negative 4 plus 2. That's negative 1/2. So that limit exists. Okay? How about the next one? The limit of f of x as x approaches negative 2. I'm going to use that same simplified expression, 1 over x plus 2, but this time I'm going to plug in a negative 2. So that's going to be 1 over negative 2 plus 2, which is 1 over 0. So that limit does not exist. Now again, it's a good idea to get an idea of what's going on here. So in this top limit, if the limit exists, then I've got something that looks like this. All right, because I knew the function did not exist at negative 4, because when I plug it in, I get something over 0. But the limit exists. So that means coming from the left and coming from the right, you're pointing to the same value. Now, in this one down here, when I plugged in a negative 2, if you notice, the limit did not exist. So that means coming from the left and coming from the right, you're not pointing to the same value. In this particular case, it represents an asymptote. Something like that. And this value right here, this x value, is going to be in a negative 2. Our third and final technique for finding a limit analytically is rationalizing the numerator. Now, if you look at this particular function, f of x equals square root x plus 1 minus 1 over x. Now, again, normally we try and use direct substitution, but I can see here I'm finding the limit as x approaches 0. If I plug a 0 in there, I get a 0 in the denominator. So one thing that we can do is rationalize that numerator. Now, we do that by multiplying by the conjugate. Now, we did this in Algebra 2 to rationalize the denominator, but here I want to do it in the numerator, because what I need to happen is I need to get rid of this problem area. That's the problem area, is I can't plug in a 0. So if we multiply by the conjugate here, I'm going to pick square root x plus 1 over square root x plus 1 plus 1. Now, the denominator I'm not going to actually multiply out. I'm just going to write those out. X times square root x plus 1 plus 1. Now, because I picked conjugates here, when I go to multiply these two, I don't really have to go through the whole FOIL process. I'm just going to multiply the first terms, which is basically just going to eliminate that radical. So that's going to be x plus 1. Square root x plus 1 times square root x plus 1 is just x plus 1. Now I'm just going to take 1 times 1. Remember, it's going to be actually a negative 1 times a positive 1, so that's just going to give me a negative 1. Well, look what happens in the numerator now. X plus 1 minus 1 is just an x. In the denominator, I've got x times square root x plus 1 plus 1. So now what happens is the x's cancel, and that's what I wanted to happen originally, because, again, that was the problem area. So now that's gone. This expression now becomes 1 over square root x plus 1 plus 1. And that is what I'm going to use now to find this limit. So now I can find this limit of 1 over square root x plus 1 plus 1 as x approaches 0. So now I can plug in my 0 in here. Okay, so let's see what happens. Square root 0 plus 1 plus 1. I think you can see here that's just going to give me a 1. 1 plus 1 is 2. So this limit is 1/2. So the limit does exist. When x is 0, y is going to be 1/2. All right, let's try one that's a little bit more challenging. So again, the first thing we would try to do, direct substitution. I can see here I'm going to plug in a negative 6. Well, that's going to be a problem. because negative 6 plus 6, that's going to be a 0. So I know I need to rationalize this numerator if I have any hope of evaluating this limit. So the conjugate of 2 minus square root x plus 10 is 2 plus square root x plus 10 over 2 plus square root x plus 10. And again, remember, in the denominator, you're really not going to multiply those out. I'm trying to get rid of this. That's the problem area right there. Okay, so I've got x plus 6 times 2 plus square root x plus 10. Now again, because they're conjugates, I just have to multiply the first. All right, so 2 times 2, that's going to give me a 4. Minus, we have to be a little bit careful here. This times this is just going to give me x plus 10, but remember, it's a negative, and it's a binomial. So I'm going to write this as minus, and then in parentheses, x plus 10. Then you have to remember to distribute your negative. So I'll do that here. I'll use a different color. X is negative and 10 is negative. Okay, so now what am I going to be left with up top? 4 minus x minus 10. Well, that's going to give me a negative x minus 6 over x plus 6 times 2 plus square root x plus 10. Now, what I need to have happen is I need this to cancel with that. And it will, but again, you have to be a little bit careful here with our negative. We have to factor out a negative. So I'll take out a negative, and that's going to be negative parentheses x plus 6. So now this cancels with that, and I'm left with a negative 1 up top. I know it's a little cluttered. I apologize, but now we're going to bring that down here. That's going to be a negative 1 over 2 plus square root x plus 10. Now I'm going to direct substitute. Okay, so let's see. Oops. Negative 1 over 2 plus square root negative 6 plus 10. Well, that negative 6 plus 10 is 4. Square root of 4 is just 2. 2 plus 2 is 4, so this limit ends up being negative 1 over 4. Lastly, I want to try a couple mixed practice examples. Example 6, f of x equals x minus 1 over x squared minus 3x minus 4. So I see a quadratic in the denominator. It's going to be easy to factor. Let's just factor this. X minus 4 times x plus 1. Now, at first glance, you're looking at this and saying, well, hey, the numerator and denominator don't cancel. What am I going to do? Well, remember, the first thing we really should do every time is try direct substitution. If direct substitution works, we're done. If I plug a 1 in here, here, and here, and I get a result that is not undefined, that is the limit. So let's try that. This is going to be 1 minus 1 over 1 squared minus 3 times 1 minus 4. Well, 1 minus 1 is 0, but remember, 0 in the numerator is fine. Denominator, I get 1 minus 3, so that's going to be negative 2 minus 4, that's going to be negative 6. That's not a 0, so 0 over any number is just 0. That is the limit. Well, hey, that worked. I'm done. Don't make it more complicated than it is. Last one. So again, try direct substitution. Well, that's going to be a problem, isn't it? Because if I plug in a 2 in that denominator, I get a 0 in the denominator. I don't care what's on the top of that. I know it's going to be undefined. So what I need to do here, because I recognize I've got this radical, is I need to multiply the numerator and denominator by the conjugate of that numerator, because I need to rationalize it. So that's going to be 4 plus square root 18 minus x over 4 plus square root 18 minus x. And again, remember, my problem area is this. That's what I need to go away. So in the denominator, I'm really not going to multiply those. I'm just going to write it out as x minus 2 times 4 plus square root 18 minus x. Now my numerator, what I need to have happen here is I need to multiply the first term. So 4 times 4, what's that, 16? Minus parentheses, and I'm going to have square root 18 minus x times square root 18 minus x, which is just going to be 18 minus x. So again, just be careful here. I need to distribute that negative. And I'll do that in different colors. So this 18 is going to be negative, that x is going to be positive. Now I'm going to combine my like terms. So 16 minus 18 is a negative 2, and I have a positive x. So that's just going to be x minus 2 in the numerator. My denominator is still this x minus 2 times 4 plus square root 18 minus x. And then you can see what happens here. Those cancel. So it's a lot of work, but I needed to come up with this expression so that now I can do direct substitution to find the limit. All right, so what this turns into is the limit of 1 over 4 plus square root 18 minus x as x approaches 2. So I'm just going to plug in that 2. And usually this works out kind of nicely. So you can see here that's going to be a 16. The square root of 16 is just 4. So that's just going to become a 4. 4 plus 4 is 8. So this limit is just going to be 1 over 8. Okay, so that concludes lesson 12.3. Again, I know I say this all the time, but please don't hesitate to reach out if you have any questions on this or want to see further other examples, and then do the homework that's associated with this lesson. Thank you.